Where did we come from? It's a question that has echoed through the ages, a mystery that has captivated scientists and storytellers alike. The story of human evolution is a long and complex one, full of twists and turns. We, Homo sapiens, stand as the sole survivors of a diverse family tree. But how did we get here? How did our ancestors spread across the globe? There are several compelling theories that attempt to answer these questions, each offering a unique perspective on our shared past. The out of Africa model, sometimes called the replacement theory, suggests a dramatic exodus. Imagine this: Homo sapiens emerged in Africa, evolving about 200,000 years ago. Then, around 70,000 years ago, they ventured out, a small band of pioneers migrating into new lands. This theory proposes that these early humans completely replaced existing archaic populations they encountered, like Neanderthals. Evidence for this theory comes from genetic studies, which show that all living humans share a relatively recent common ancestor from Africa. This model paints a picture of a single origin for our species, a bold departure from our evolutionary cradle. The multi-regional hypothesis offers a contrasting view, emphasizing interconnectedness. Instead of replacement, it proposes continuous evolution. Imagine archaic humans like Homo erectus leaving Africa much earlier. They spread across the globe, evolving into distinct regional populations. According to this theory, modern humans emerged gradually, with gene flow connecting these different groups. This constant exchange of genetic material ensured that humans remained a single interbreeding species. Evidence for this theory comes from fossil records, which show some regional continuity in anatomical features over time. This model highlights the deep roots of our species, suggesting a more interconnected and less linear evolutionary path. The partial replacement model seeks a compromise, acknowledging the complexities of our past. It suggests that Homo sapiens did indeed originate in Africa. Like the out of Africa model, it acknowledges the migration of these early humans. However, it proposes that instead of complete replacement, there was interbreeding with existing archaic populations. This model acknowledges the genetic evidence pointing to an African origin, while also explaining the persistence of certain archaic traits in modern populations. This theory suggests that our evolutionary story is not a simple tale of replacement, but a complex tapestry woven from both interaction and isolation. While each theory has its strengths, the partial replacement model currently holds the most weight in the scientific community. It best explains the genetic evidence pointing to a recent African origin for all humans. It also accommodates the fossil and archaeological evidence suggesting some level of interbreeding between Homo sapiens and other archaic humans. The story of human evolution is not yet complete. New discoveries constantly refine our understanding of the past. As we continue to explore our origins, we will undoubtedly uncover even more fascinating chapters in the saga of our species.